So, good afternoon, everyone. My name is Anishes. I'm from fourth sem Information Science Department RSCE. So, I'll be explaining about context-sensitive languages and context-sensitive grammar. So, before going into what is context-sensitive grammar and language, let us look at the basic Chomsky hierarchy that is present in today's world. So, basically, what is Chomsky hierarchy? Chomsky hierarchy is a system of classifying formal languages. So, first, in the basic most level, as shown in this diagram, there's regular language, then there's context-free language, then there's context-sensitive language, and then there's recursively enumerable language. Today, for this presentation purpose, I'll be explaining context-sensitive languages and context-sensitive grammar. So what is basically context-sensitive language? So let me explain it to you in terms of simple terms. So first off, assume there's a transition taking place from A to X. And so whenever there is a derivation, a certain amount of derivations represented by, some characters or dots. So let there be a few number of, symbols before A. And whenever this grammar encounters an A, it replaces A with an X, and then the respective other derivations take place and goes on. This is the example of how context-free grammar takes place. In context-sensitive language, not just A, but the context around A, that is the surrounding symbols, like the symbols left of A and the right of A is also considered, which, which is necessary in some application that we study. So basically, in context-sensitive language, when we're doing a transition or when we're doing a derivation, we are considering the surrounding symbols, which is also known as context in this case. So why was this established? In some cases there is linguistic complexity. So in linguistic complexity also means like languages which are very complex or which cannot be described by context-free grammars. Context-sensitive languages allows for rules because of the context of the alphabet as is present next to it or something. And then this was also used in DNA and bioinformatics because genetic sequences was a large data set which had so much modeling patterns. So because of this, the context of one protein and the protein next to it also was necessary for creating a derivation. So basically, this was why it was established. The motivation for establishing a context-sensitive language. So let us look at the formal derivation. So let us consider a tuple. Like basically, it is of the form alpha x beta, which forms alpha y beta. So I'll explain it to you. So basically, it is of four tuples: G of V, T, S, P, where V represents the variable states, T represents the terminal states, P represents the production rules, and S represents the start state. So this is what basically it represents. There are basically two rules that is formed here. One thing is that in the left hand side, there should be at least one non-terminal state present, and on the right hand side there should be no epsilon present. So I repeat the two rules again. Basically, on the left hand side there should be one non-terminal state present, and on the right hand side there should be no epsilon present. That is at least one state should be present. So that is why they've given x and y belong to v u t plus. Since it is t plus in this, T plus means that at least one should be present. If you had written T, V union T star, it means that any number of V or T can be present, including epsilon. But here we have made it a point to write it as plus, which emphasizes that there should be at least one thing present on the right hand side. And there's another rule saying that modulo of x is less than equal to modulus of y. So basically, what this means is that the right hand side should be always greater than the left hand side or something like that. So let us take one example to solve this. So let us take so again, before taking an example, let me define what is a context sensitive language. A context sensitive language is a language which can be derived from context free grammar and context sensitive grammar. And context sensitive grammar, as defined before, is the thing which contains 5 tuples, which has 2 rules or something like that. So let us look at this example whereas we want a language which has variables a par n, b par n, c par n, whereas n is greater than 1. So the possible languages for this are A, B, C, A, B, B, C, C, triple A, triple B, triple C, or something like that. So here we've defined the start state as A, B, C, and we've also made it A B C, wherein state A is defined as AB, which can be reversed as BA. AC is reversed as BBCC. This is to ensure that there is equal number of A, B, C present in the language. If you had not written AB is equal to BA, it gives rise to BA, then there would be n number of A's but not equal number of B's and C's present. So like this is how the language is developed. Let us look at the applications of context sensitive languages and its computation. So context sensitive languages, again, as I told, why it was established was again type checking, scoping, syntax analysis. Syntaxes wherein contains many number of symbols. So to know where the derivation is happening, the context around it is also necessary. NLP, wherein AI modeling or something like that is also necessary. And then DNA and genome analysis, as I said, all these proteins have so much complexity that the context is necessary. Again, human machine interaction, compare interpreted design, natural language generation, and contextual advertising. These are the some ways. These are the some applications of context sensitive language. Again, to summarize, context sensitive languages are a part of the Chomsky hierarchy, wherein first comes regular language, then comes context free language, then comes context sensitive language. Context sensitive language is basically when the context of the derivation is also necessary, not just the symbol. And then it was established because of all the motivation reasons that I provided, like the complexity of the language or something like that. And the formal definition of the four tuples and how the two main rules. First rule stating that the left hand side should have at least one non-terminal state and the right hand side should not have an epsilon state. And again, we showed with an example and then the application. So thank you.